Namaskara friends, welcome to my channel. I am Rakesh P. Naik. In this video, we will learn how to do modeling, analysis and design of a residential building using E-TABS software. And in this video, we will be covering everything from basics, and I will make sure that there will be no doubts left in your head after completely watching this video. Now before opening the E-TABS, let me show you certain steps which we have to follow. For that, let me click on Word. Here you can see the steps which we have to follow, and I will explain each steps completely with proper demonstration. So without further delay, let's do the structural design using E-TABS. For that, just a double click on the E-TABS icon which is visible on your screen. Wait until it opens, it will take some time. The user interface looks like this. So here you can see there are two options. First option is new model, second option is open existing model. If you want to create a new model, select the first option, and we will select the second option when we have already started modeling but we haven't completed our work, or we want to revisit the existing model. Since we are doing a new model, we will proceed with first option. Let me click on the first option. After clicking on the first option, you can see a mini window like this. In this window, we have to provide the information regarding the type of code which we want to prefer and the type of unit which we want to use. So okay, here you can see three options: use saved user default setting, second one is use setting from a model file, and third one is use built-in settings with. If you are regularly using E-TABS, then you can save certain setting which you prefer. In that case, you can proceed with the first option. Coming to third option, in third option you can customize your preferences. Like I will click on the third option. Here you can see you can select the type of SI unit you want, and you can prefer any type of code you want to follow. Here you can see in first one we will select metric SI, and in second one we will select Indian. So coming to steel design code, we will select IS 800 2007. Coming to concrete design code, we will select IS 456 2000. After completely filling these boxes, click on OK. So now here you can see a new tab. So in this tab you have to provide the information regarding the grid system. So let me explain what is grid system. Grid system is a systematic arrangement of grid lines, and the grid lines are the reference line with help of which we can draw the different structural element inside the E-TABS. First we have to mention the grid dimension. In this we can see there are two options. First one is uniform grid spacing and second one is custom grid spacing. We will move with the first option when the spacing between the grids is uniform in x direction, and it is also uniform in y direction also. And we will move with the second option when the spacing between the grid is non-uniform in either any one of the direction. So we will click on custom grid data, then we will click on edit grid data. So you can see a new window will open up. Okay, in this tab we have to provide the data regarding the grid system, and there are two options available for that. You can see the first option is display grid data as ordinate, and second option is display grid data as spacing. I will explain both of them. Let me explain second one. For that, let me open AutoCAD. So here you can see in this manner we have to provide the spacing between pairs of the grid lines. Here you can see this is the spacing between the pairs of the grid line, that is 10 feet, 10 feet, 5 feet. In this manner we have to provide the data using the second option. So let me show you how to enter the grid data using the second option. For that I will click on the second option. So here you can see I will provide the first ordinate spacing as 5 meter, and here you can see the grid system has changed here, and the third ordinate will be at a distance of 4 meter from the second ordinate. Third ordinate will be at a distance of around 6 meter, So here you can see the grid system is altered. Now I will teach you how to enter the grid data using the first option. For that I will click on the first option. So let me explain that using a diagram. So here you can see a diagram. This is a coordinate system. So when we enter the data using first option, E-TABS will process that data in form of the coordinate system. Okay. When we provide the spacing of the ordinate, we are specifying the position of the each ordinate from a reference line. Here you can see this y coordinate axis will be the reference line. From this reference line, the position of the each ordinate along x direction is specified. Now we will enter the grid data of the residential building using first option. So let me click on the first option. So before entering the data here, let me tell you some of the good things about the E-TABS. So the first thing is you can directly enter the spacing in terms of feet or inches. The E-TABS will automatically convert the whatever the unit of the spacing you have provided into the meter. So let me show you guys. I will enter spacing of 6 feet here and I will press on enter. So here you can see the E-TABS itself converted the feet into the meters. So the next thing is the E-TABS enables you to do certain mathematical operations like addition, subtraction, multiplication and division in this data entry box itself. Let me show you that. So I will double click here. So here you can see I will enter 2 plus 2. So you can see that it has performed the mathematical operation. Like this I can do the division also. So I will enter 10 by 2 and I will press enter. So you can see we can do the 4 basic mathematical operation in this entry box itself. These two options are the pretty good things about the E-TABS. So now I will enter the grid data of the residential building. For that I will open CAD file. Here you can see this is the plan of the residential building, that is architectural plan of the residential building, and this is the elevation of the same building. And once we get the architectural plan, first thing which we have to do is we have to fix the position of the beam and column inside the layout. So for fixing the position of the beam and column, we have to consider two criteria. First one is architectural criteria and second one is structural criteria. Coming to architectural criteria, in case of the architectural criteria, we have to place the beam and column in such a way that it shouldn't hamper the aesthetics of the building. For example, we just cannot directly place the beam at the middle of the living room, or we just cannot project the face of the beam and column from the face of the wall. It just doesn't look good. Next, coming to structural criteria. In case of the structural criteria, we have to place the column in most symmetric manner as possible, and coming to individual column, we have to place the individual column in such a way that the longer dimension of the column cross section should be facing towards the maximum bending moment. How to know where the maximum bending moment is acting? We can know where the maximum bending moment is acting by knowing the span between the columns. If the span between two columns is maximum, then the maximum bending moment will be acting along that span only. Then why it is necessary to place the column along the longer dimension? Because along the longer dimension, the second moment of area of the column will be more, and the second moment of area of the column is the resistance offered by the geometry of a section against the bending. And for example, here you can see that I have provided the longer dimension of the column along the maximum span so that it can resist the maximum bending moment. So after fixing the position of the column and the beam, next thing what we have to do is we have to prepare a central line diagram using architectural plan. So here you can see this is the central line diagram of the building. From this central line diagram, we can easily draw the grids in E-TABS. So here you can see the first grid line is present at a distance of 6.5 feet. I will enter 6.5 feet here. So the first line will be at an ordinate of 0, then the second line will be at an ordinate of 6.5 feet. I will enter 6.5 feet. Let me enter second grid spacing, and the second grid is present at a distance of 10 feet. Okay, I will enter 10 feet here. So So now we have to specify the last grid spacing. So that is 8 feet, and that is around 8.5 feet. So I will enter 8.5 feet. I'm not going to exactly enter the grid spacing because it will consume more time, because I have to convert those inches to feet and then enter data. It will be time consuming, so I will enter some approximate spacing. Here I will enter 8.5 feet. So since we are measuring it from the reference line, I will add the above spacing 3.048 meter. So we have successfully entered the grid data along x direction. Now we have to enter the grid data along y direction. So basically we have to follow the same procedure which we have followed to enter the data along x direction. So here you can see, to save the time, I have already entered the data along the y direction. So we have completed the grid data entry. Now we can change the bubble size here. So I will provide the bubble size of 500 mm. So you can see now the bubbles are clearly visible and they are not overlapping. So now I will click on OK. So we have completed the grid data entry. Now in this portion we have to provide the data regarding story of the building. So the grid data entry is related to plan of the building. Here we have to provide the data regarding the story of the building. So you can see there are two options available. One is simple story data, second one is custom story data. If each story of the building has the similar height, then we can select the first option. If each story has the different height, then we can proceed with the second option. So in our case it will be a two-story building and each story having the same height, so we will proceed with the first option. So for that, let me enter number of story. There will be three number of stories, and coming to typical story height, it will be 3.1 meter. It will be 3.1 meter, and the bottom story height will be of 5 feet. The bottom story height means the depth of the foundation or the depth of excavation, and the depth of excavation cannot be less than 4 feet. It should be at least greater than 4 feet. So I have provided 1.5 meter, which is greater than 4 feet, and we have successfully entered all data. Now I will click on OK. So here you can see we have successfully created the grid system. The next step will be defining the material. So let me open E-TABS. So to define the material, we have to click on the define, and after that click on material properties, then click on add new material. So here select India and then select concrete, and here standard it will be India. After that select M25 concrete. So we generally use M25 concrete for the construction of the beam and column in case of the residential building. That's why I have selected M25 concrete. After that click on OK. So here you can see these are the properties of the material. The first one is material type, it is concrete. Then the directional symmetry. In directional symmetry we have two options, one is isotropic and second one is orthotropic. Isotropic means the material which has the same elastic property in all the direction, whereas the orthotropic means the material which has the same elastic property in three mutually perpendicular direction. So concrete will be isotropic material, but so if we use the wood, then we should select the directional symmetry as the orthotropic, because the wood has the different elastic property in three mutually perpendicular direction. So after that we can see material display color. I will not change the material nodes. If you want to add any nodes, you can add. After that we can see the material weight and mass. So there are two types of density. One is specific weight density and second one is the mass density. You can enter any one of them. Here you can see the weight density, which is around 25 kilonewton meter cube, which is pretty accurate. I will proceed with the weight density. Then you can see the material property data. Here you can see the modulus of elasticity, which is 25,000 MPa. The modulus of elasticity is the ratio of the stress to strain, and we can calculate the value of this modulus of elasticity using the code book. So for that we have to refer IS 456 code book. So here in page number 16 of IS 456 you can see that they have provided the formula to calculate the modulus of elasticity of the concrete, and they have mentioned that it is the short term static modulus of elasticity and its unit will be in Newton per millimeter square. So in case of the concrete there are three types of modulus of elasticity. One is initial tangent modulus of elasticity, second one is secant modulus of elasticity, and third one is the tangent modulus of elasticity. So this is the stress strain curve of the concrete, and you can see that it's clearly showing the non-linear behavior. When the material shows the non-linear behavior, the modulus of elasticity of the material along each point will be different. So we cannot directly use one modulus of elasticity. So for that we have to select the multiple point and we have to draw the tangent there and we have to calculate the modulus of elasticity. So here you can see the first tangent. So the slope of this tangent will be the initial modulus of elasticity. The slope of this tangent will be the tangent modulus of elasticity. In order to calculate the tangent modulus of elasticity, we can draw the tangent to the curve at any point beyond the elastic limit. So this point will be the point of elastic limit, and this dotted line, the slope of this dotted line will represent the secant modulus of elasticity. So we use the secant modulus of elasticity for designing the building for the static loading condition, and we use this tangent modulus of elasticity for designing the earthquake resistant building. So according to IS 456 code, to calculate the secant modulus of elasticity, we have to divide the cube strength of the concrete by 3, that is FCK by 3. From a strength of FCK by 3, we have to drop an offset, and this offset will intersect the curve at any point. Then we have to join the origin and the point at which the offset intersect the curve, and the slope of the line joining these 2 points will be the secant modulus of elasticity. So this is the empirical formula provided by the IS 456 code to calculate the Young's modulus of elasticity in absence of the test data. So here you can see the formula is 5000 under root FCK. FCK means the characteristics compressive strength of the concrete, and since we have used M25 concrete, if we put M25 here, this whole term will be 5. If we multiply the 5 with 5000, then we will get the 25,000 MPa. So here you can see they have mentioned the modulus of elasticity to be short term static modulus of elasticity. So coming to static modulus of elasticity, there are two types of modulus of elasticity. One is short term static modulus of elasticity and second one is the long term static modulus of elasticity. The long term static modulus of elasticity accounts for the long term effect like creep and shrinkage. So here you can see the value of the modulus of elasticity is 25,000 MPa, which is same as we calculated. Next, coming to Poisson's ratio. Poisson's ratio is the ratio of the lateral strain to the longitudinal strain. Practically saying, the Poisson's ratio is the parameter which describes the amount of lateral deformation in terms of the longitudinal deformation, that too in percentage. Okay, and the value of Poisson's ratio varies between 0.1 to 0.3. Here it is 0.2. I am okay with it. Then coming to coefficient of thermal expansion. The coefficient of thermal expansion is strain itself, but it is the strain due to the unit change in the temperature. Now coming to the value of coefficient of thermal expansion. The value of coefficient of thermal expansion depends upon the type of aggregate we use in the concrete, and to know the value of coefficient of thermal expansion we have to refer IS 456 2000 code book. So in same page, that is page number 16, we can see that the value of coefficient of thermal expansion for the concrete with different type of the aggregate used. Generally we use the granite as the aggregate during the preparation of the concrete, so we will select this value, that is 0.7 to 0.95 into 10 raised to minus 5 per degree Celsius. So here I will enter 90. Okay, we have entered the coefficient of thermal expansion. Now shear modulus G, or it is also known as modulus of rigidity. So modulus of rigidity, it is the ratio of the shear stress to the shear strain. So after that we have the design property data. If you click on this, you will have the list of the design property data of the concrete. So in this tab here you can see the material name and type. So we have already provided this data, that is the material name is 125, material type is concrete isotropic, and the grade is M25. And then coming to design property for the concrete material, you can see the concrete cube strength FCK. So this M25 grade is the desired strength. This is the minimum strength which we want. Here you can see the concrete cube strength. The concrete cube strength after performing the test can be greater than this the desired strength. In such case you can enter the cube strength in this box. So I'm not going to change this. So if you are using the lightweight concrete, then you can click on this box and you can design your structure. In this case we are not using the lightweight concrete, so I will unclick, and after this I will click on OK. So data which we have provided in this tab is sufficient for a residential building. So in case of advanced design, you can enter the property using these options. So I'm not going to enter the advanced material property data since our building or our structure is a simple structure. I will click on OK. So we have provided the data regarding the concrete. Now we have to add another material, that is rebar. For that, click on add new material. After that, here click select Indian, and here select rebar, and here select HVSD grade 500. So Fe415 grade is no more available in the field, so everyone are using the steel having grade greater than 500. That's why I have selected HVSD grade 500. So after that, click on OK. So these are the properties of the rebar. If you want to change anything regarding the properties of the rebar, you can change, and I will check certain properties like mass per unit volume, that is the density, which is 7850 kg per meter cube. It is accurate. Then the modulus of elasticity, which is 2 into 10 raised to 5 MPa. It's also accurate, and everything seems accurate. I will click on OK, and we have successfully defined the both the material which we use in the RCC, that is concrete and the steel. And now I will click on OK. So we have successfully defined the material property. Now we have to define the section property. For that, click on define. After that, click on section properties, and after that click on frame section here. So now coming to structural engineering, the frame means combination of column and the beams which are connected by the joints. So in order to add the new beam and column, we have to click on add new property. I will click on add new property. So here you can see we have the new tab. So here we will select concrete rectangular, since the shape of the beam and column which we have provided is rectangular. So we will go with concrete rectangular. We'll click on concrete rectangular. So here we have to provide the name to the section. I will provide name as 9 into 9 column. So after that we have to select the material. It will be M25 concrete, and here we have to provide a dimension to the section. It will be a column of 9 inch into 9 inch. So I'll provide depth as 9 inch and width also of 9 inch. So after that, click on modify show rebar. So in this tab we have to provide the information regarding the reinforcement data. Since we are designing the column, we will check the first option, this option, and after that rebar material. Here we have to select HVSD 500. So confinement bar also we have to select HVSD 500. After that, coming to reinforcement configuration, it will be rectangular, since the shape of the column and the beam is also rectangular. The confinement bar, it will be tie. When it is a rectangular column, it will be spiral when the column is circular. Then chuck or design, here we have to select reinforcement to be designed, not reinforcement to be chucked. After that, we have to provide the information regarding the longitudinal bars. Here the cover will be 40 mm. It's okay, correct. And the number of bar along direction 3 3. So the direction along this axis will be the direction 3 3, and the direction along this axis will be the direction 2 2, and along both direction the bar will be 3 numbers. So I will enter 3 here. So for the longitudinal bars I will select 12 mm, and for the corner bar I will select 16 mm. After that, coming to confinement bar size, I will select 8 mm here. So confinement bar means the lateral ties. So after entering all the data, click on OK. So if you want to see the section properties, then you have to click on this show section properties. So here you can see these are the section properties. The first one is the cross sectional area, and the second two are the shear area, and this is the moment of inertia about a respective axis, and these are the and these are the section modulus, and this is the radius of gyration, and we have the plastic modulus. This is the polar moment of inertia, and a CG offset from direction 3 3. So after verifying all the data, you can click on OK. If you have the good basics of strength of material, then you can manually calculate this parameter, and you can verify your results with the results of the E-TABS. So I will click on OK. Now we have entered all data. I can click on OK here. So you can see the 9 into 9 column is successfully added. Now we have to define the remaining column. For that we can just copy the previous column, and we can change the name and dimension of the column. So in order to do that, first click on the column which we want to copy. I will click on 9 into 9 column, and then click on the add copy of the property. So here you have to enter the name of the new column. So I will enter it as 9x12" column. So after that the only thing which we have to do is we have to change the dimension. That is, here I will provide 9 inch. After that I will press enter. So you can see we have entered all data, and remaining data will be same since we have copied the previous column. So everything will be same. Just click on OK. So the new column, that is 9 into 12, is added. So in this manner we have to add the remaining column. We have defined the column section. Now we have to define the beam section. For that I will click on add copy of the property, because the beam is also made up of the same material, which is RCC. So I will click on add copy of the property. So here I will provide the name as beam 16, and the depth of the beam will be 16 inches, and the width of the beam will be same. So only thing which we have to modify here, click on modify show rebar. So here, since we are designing the beam, click on the second option. After that change the cover. So for the top bars the cover will be of 1 inches, and for bottom bar also I will provide cover of 1 inch. So after this click on OK. So we have entered all data, then click on OK again. So here you can see the beam is successfully added. So for the floor beam as well as the plinth beam we are using same size, so that's why I have defined only one beam here. So we have defined all the section property. Let me click on OK. Now next we have to define the slab section. For that I will click on define, and from the section property I will select slab section. So here we have to click on add new property. So here we have to provide the name. I will provide the name as slab 150, and here I will select the material as M25. So here we have to select shell thin, and here we have to specify the thickness of the slab, which will be 6 inches, and then I will click on OK. So we have successfully added the slab. Then I will click on OK. So after defining all the section properties successfully, now we have to draw the beam column and slab, and we will start with the beam. To draw the beam we have the two options. The first one is this option, that is the first one is this option, draw beam column brace, and second one is this option, quick draw beam columns. and I will show how to draw the beam using the first option. So for that, click on this option and then select the beam which we want to draw. We will select beam 16 here, and to draw the beam, just click on the node, and this point is known as the node, and after that click on the another node or at any point up to which you want to extend the beam. So I will click on the next node. So here you can see the beam is successfully drawn. So I will click escape. So in this manner we have to draw the beam using the first option. Now I will show how to draw the beam using the second option. For that, I will click on the second option, and from here property, I will select the beam 16. So I will select the beam 16. Now place the cursor over the grid line and then right click on the grid line. So you can see the beam is automatically assigned here. In the same manner, you can place the cursor wherever you want on the grid line, and right click on the grid line. You'll see the beam will be automatically assigned. In this manner, we can draw the individual beam using the this second option. That is a quick draw beams. And if you want to draw the all the beam at once and all the beams are present along the grid lines, then you just have to click at one part and then select all the beams and release the button. Then you can see here all the beams are assigned to the grid line. So in this way you can draw the beams using the second option. Or if all the stories of the building has the same beam layout, then you can draw all the beam at once, and let me show you how to do that. For that, select the cursor here and select all the beam and press delete. So all beams will be deleted. Now select quick draw beams option, and then here you can see a drop down box at the bottom right corner. So click here and select all stories. Now click at this point and drag the mouse upwards and select all the grid lines and release the mouse. So here you can see the beam layout is assigned to all the stories. So we can do the same thing in another way also. For that, click on cursor and select all the beams and press enter. Now quickly select the quick draw beam and here select one story and drag the mouse upwards and assign the beam to one story. Here you can see the beam is assigned to the top story, and if you want to replicate this beam to different story, then click on edit. Here you can see edit, and here select replicate, and inside the replicate select story, and again just select the cursor and select all the beams, and here select the story at which you want to replicate these beams. I will select story 1 and click on apply. So here you can see the beams are assigned at story 1, and similarly select all the beams and click on apply. So here you can see the beam are assigned at story 2. So in this manner we can draw the beams at different story with minimum effort. So I will click on OK, and now I will show you guys how to draw the secondary beams and the cantilever beam. Let's say the secondary beam is resting on these two beam and it is resting at the center, and so in order to draw the secondary beam, just right click on the mouse and here select snap option, and here select line ends and midpoints, and then here click on apply. After that, close this tab, and now select the beam, and here you can see the midpoint is visible, and from this point to this point just draw the beam. So in this way you can draw the secondary beam. Let me show you how to draw the cantilever beam. For that, I will delete this line, and for that, now what we have to do, let's say the cantilever beam is present at now let's say the cantilever beam is present at this portion. Now I will select this grid point, and then I will click on edit. After that, click on replicate. So here you can see this direction is x direction and this direction is y direction, and let's say the cantilever beam is of length 1 meter, so it will be extending in x direction. So here I will enter 1 meter, and after that click on apply. So here you can see the joint is replicated to a distance of 1 meter from its original position. Now click on OK. Here select the draw beam tool, and now click on this grid point here, and after that click on this joint. So here you can see we have successfully drawn the cantilever beam. And there is another way to draw the secondary beams. For that, here click on quick draw secondary beams, and here select the beam 16, and here we have to provide how many number of secondary beams are present, and we will enter, let's say we will enter 3 number of beams and they are present at equal spacing, and I will press enter. So here you can see it will add the secondary beams like this. You can change the direction by clicking here. Here select parallel X or T, and then you can see the orientation or the direction of the beam is changed. So in this manner you can draw the secondary beams quickly. Now let's draw the beams of the residential building. For that, let me quickly delete all these things. So here I will select all stories, and I will select entire beam and press delete. So here you can see everything is deleted now. Now I will open this PDF. So here you can see here only one beam is present along this grid line, and in the hall the beam is present along this grid line, and then in next portion the beam is present along this grid line. So let's quickly draw the beams of this residential building. Now for that, here select one story, and now here I will select draw beam, and we will draw the beam from this grid to this grid point, and next from this grid point to this grid point, and in the same manner we will draw all the beams from the grid. So here we have here, and from this point, from this point, and from this point to here, from this point to this point. Okay, see, and here is the same thing. Then here to here, here, and then from this point, here, and again from this point to this point, here, this point, here, and then here to here, here, this side, this point, here to here, and we have successfully assigned all the beams. Before moving further into the video, let me explain some of the important command. So in that, the first one will be, here you can see this one is the elevation. Let's say you want to see the elevation of your structure. For that, click on window like this, and then click on elevation. So a mini window like this opens up, and then select any of the label and click on apply. So here you can see this is the elevation of the structure, and if you want to navigate through the different elevation along different grid lines, you can select those grid lines and click on apply. So here you can see this is the elevation of the building along grid line B. So this is the B1, B2, B3, B4, B5. Okay, and in similar way, if you want to see the elevation of the building along grid line C, then select C and click on apply. So this is how you can navigate through the different elevation along different grid lines. If you want to navigate along different grid lines, then there is another way. So that is these arrow marks. Just by clicking on these arrow marks, you can directly navigate into the different elevation like this. If I click on this arrow mark, you can see that you are navigating to the different elevation along the grid lines. So this is about the elevation. I will click on OK now. Now second one is the plan view. So click on the window on which you want to see the plan. So I will click on this window, and after that click on plan. So then select any story, and I will select story 2. So here you can see this is the plan of the story 2. If you want to see the plan of the story 4, then select story 4 and click on play. So this is the plan of the story 4. In this way you can navigate through the different plan also. And there is another way, that is clicking on this arrow mark. You can directly navigate through the different plans like this. So if I click on this downward arrow mark, I will move in the top to bottom direction, that is from top story to the bottom story. Here you can see I will click on this arrow mark, and I will again click on this arrow mark. So now we are at first story, which is present at a height of 4.624 meter, and I will again click on this. Here you can see now we are at the plinth level. This is the plinth level of the building. So this is how you can navigate through the different plans also. And then you have the 3D view. If you want to see the 3D view of the structure, just click on the window and then click on the 3D. So you can see this is the 3D view of your structure. Now let's assign the beam to the different stories. So before that, here you can say some of the extra beams were added. So let's delete these beams. So here I will select these beams. This is the first beam, second beam, and this is also third beam, and I will delete these beams. So now let's select this entire beam layout, and after that click on edit and then click on replicate, and here click on story. So we will replicate these beams to the story 1, 2, 3, and now we are present at story 4. Then I will click on apply. So here you can see the beams are successfully assigned to all the stories. Okay, now I will close this tab. Now we have to assign the column. For that, click here and select all stories, and now select this option, that is quick draw column. Now just place the cursor over these points where we want to draw the column. So here, before that, I will select the column of 9 into 9, and I will provide the column of size 9 into 9 at several point, and let me click on this point. So here you can see the column is successfully added. So in same manner I will provide all the column. So and here also, and here also, and here also, and here I will select column size 9 into 12. So here is 29, and I provide same here, 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 and here, and this here, and here. So here you can see now we have successfully assigned all the column. Now the next step is to assign the giant. For that, click on all stories. Here click on story, and here move to the bottom story like this. Now select all the giants here, and after that click on assign. Here select giant, and after that select restraint. So here select fixed support. So you can see all of the columns of the building are strongly embedded inside the footing, and footing do not allow the rotation of the column, and it doesn't allow the movement of the column in the vertical and both in the horizontal or lateral direction. So it will be the fixed support. After clicking on the fixed support, then click on apply, and after that click on OK. Now we have successfully assigned the joint. Now next step is to draw the slab. For that, go to the top story, and now I will select draw the floor wall command, and after that here I will select slab 150, and I will draw the slab. To draw the slab, first click on the first grid point, and then click on the second grid point, and then again click on the third grid point, and then fourth grid point, and then again first grid point. So here you can see the slab is successfully assigned. And there is another way to draw the slab, and that is quick draw floor wall, and select this, and here select slab 150, and here you can see you can quickly draw the slab using this command. So let me show you. Just click on the panel on which you want to draw the slab. So here you can see I have clicked here, here, and here. So in this manner we can quickly draw the slab. Here, click here, then click here, and click here, then click here, go here, then go here, so click here, then click here, so click here, 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 and here. So click this one, this one, this one, this one, this one, okay, so this one, click here. So here you can see we have successfully drawn the slab, and if you want to replicate these slab to other floor, just select all the slabs like this, and then click on edit. Here click on replicate, and here click on story, and now select story 3, 2, and unclick story 4 and story 1, because at the story 1 the plinth beams are present. Since we are already applied this slab on story 4, now we need to apply this slab on story 3 and story 2. For that, I will click on apply. So here you can see these slabs are successfully assigned. So let's check the slabs are successfully assigned or not. So the one slab is missing here, and okay, we will draw that slab. So let select this command, hit slab command, and then just click on here. So we have successfully drawn this floor, and just click on here. So now you can see we have successfully drawn all the slab. Let's view the rendered view of our structure. So here you can see this is the rendered 3D view of our structure. This is how it looks like. So whether all the members are properly created or not, you can check using this render view. So this looks okay. So we have completed the modeling. Now we have to check our model. For that, click on analyze. After that, click on check model, and then give the length tolerance as 1 mm, and then select all the checkboxes by clicking on this option, and then click on OK. So it will analyze our model. It will take some time. So here you can see no warning messages were generated. If we have done any error during the modeling of the structure, then those error will be shown to us in terms of the warning messages in this tab. So after that, we have to look at those errors, whatever error we have committed, and we have to rectify those error or mistake. And warning messages will be like the members are too close, the members are overlapping. In this manner, the warning messages will be generated in this tab. So in this case, there is no warning messages. So I will close this tab. Now we will assign the load on the building. So before assigning the load on the building, we should know what are the type of load which are acting on the building. So the major load which are acting on the building are the wind load, earthquake load, dead load, live load, and slow load. These are the major load. Other type of load are also acting on the building. And since our building is a very small building and it is a simple building, we do not consider the dynamic loading such as earthquake load and the wind load. We only design our building for the static loading condition, that is the live load, combination of the live load and dead load. So after knowing the type of load acting on the building, now we have to calculate those load. So in order to calculate the load, we have to refer the code, and the code which we refer for the calculation of the load is IS 875 part 1, 2, 3. We have to refer all these three code for the calculation of the loading. Now let's start the load calculation. First we will calculate the dead load. Coming to dead load, we only have to calculate the dead load due to the self-weight of the wall and the dead load due to the floor finish, because the dead load due to the frame section such as beam, column, and the slab will be calculated by the E-TABS itself. So let's calculate the dead load due to the wall first. For that, I will open the Excel sheet. So in order to calculate the dead load due to the self weight of the wall, we should know what is the unit weight of the brick masonry. For that, we have to refer IS 875 part 1. So I will open IS 875 part 1. So here you can see in page number 10 of the IS 875. This is the page number 10 of IS 875. So here you can see the unit weight of the brick masonry is 18.85 kilonewton per meter cube. Okay, this will be the unit weight of the brick masonry which we will consider. Now let's calculate the load acting on the beam due to the self weight of the wall. So we know that the wall rests on the beam, and the wall will apply the load on the beam which is uniformly distributed throughout the length of the beam. So we consider the load of the wall to be uniformly distributed load, that is UDL. So we can calculate the UDL by using this formula, that is cross sectional area of the wall multiplied by the unit weight of the brick masonry. So here in the load calculation you can see, I will click. So here you can see this is the unit weight of the brick masonry, and this is the thickness of the wall multiplied by the height of the wall. This term will give us the cross sectional area of the wall. So cross sectional area of the wall multiplied by the unit weight gives us the load in terms of the UDL. So here you can see the UDL of intensity 12.55 kilonewton per meter is acting on the beam. And now we have to calculate the load due to the self weight of the floor finish. Floor finish means the material which we use for the flooring, such as the granite, marble, and the tiles. And before laying this floor finishing material, we lay a cement mortar bed, and we also have to consider the load due to this cement mortar bed also, along with this floor finishing material. And generally in structural engineering, while designing the any type of building, we generally use the value of the floor finish to be 1.5 kilonewton per meter square. since the floor finish is acting on the slab and it spread over entire area of the slab, we apply the floor finishing load in form of the pressure. So here you can see its unit is kilonewton per meter square, which is the unit of the pressure. And now we have to calculate the value of the live load. For that, we have to refer IS 875 part 2. So I will open IS 875 part 2. So here you can see this is IS 875 part 2. In page number 7, here you can see this is the table for the live load for the different type of building. So our building is residential building. In this, here you can see for all rooms and kitchen, the value of the live load is 2 kilonewton per meter square, and for the toilet and bathroom it is also 2 kilonewton per meter square. So we will use this value of the live load. So let me close this tab. So here you can see I have used the value of the live load as 2 kilonewton per meter square. So we have completed all the calculation. Now we have to assign this calculated load to the frame section. So for that, let me open the E-TABS. Now I will apply the load on the slab section. For that, click on select. In this again, click on properties and then click on slab section. So here select slab 150 and click on select, and here you can see all the slab sections are selected. And then in order to assign the load, click on assign, and here click on shell load, and then here click on uniform. So first we will apply the dead load. So we have calculated the intensity of the dead load, that is 1.5 kilonewton per meter square, which is the floor finish. Then we will apply now. So here you can see the dead load is successfully assigned, and now we have to apply the live load. So click here and select live, and then here enter the intensity of live load. So the intensity of live load is 2 kilonewton per meter square. And now here again click on select, and then here click on apply. So here you can see the live load is also successfully assigned. And now we have to assign the load to the frame section. So I will click on OK here, and I will close this tab, and then again click on this select option, and then here click on the properties, and here select the frame section, and then here you can select the beam 16, and then click on select. So all beams are selected, and then go to the assign, and here select the frame load, and here select the distributed load. So we will apply the dead load, that is the load due to the self weight of the wall, and its intensity will be 12.5 kilonewton per meter. So after entering the load, click on apply. So here you can see the load is successfully applied on all the beams. Okay, in this way we can apply the loading. But according to the architectural plan, the main wall is present along the periphery of the building only, and on this interior beam, the partition wall is resting. So we have to quickly calculate the load due to the self weight of the partition wall. For that, let me open this Excel, and here I will enter the thickness of the partition wall, that is 0.115 meter, and I will press enter. So you can see the load of the partition wall is around 6.5 kilonewton per meter. Now I will select this interior beam. Before that, let me click here and select all the stories, and I will select this interior beam one by one. And so I have selected all the interior beams, and now I have to apply the load on these interior beams. For that, I will click on assign, and then frame loads, distributed load. Here the load due to partition wall will be 6.5 kilonewton per meter square, and after that click on apply. So here you can see on interior wall the partition load is successfully applied, and now I will click on OK. So here you can see this is how the uniformly distributed load is acting on the beam of our structure. This is the partition load, and this is the main wall load. Okay, and if you are sure that your client will not extend the building in the future, then at the terrace floor, so you can apply the load due to the parapet wall only, that is on beam only. On the slab you have to apply both live load and the dead load due to the floor finish. We have successfully assigned the load to the frame section, and now we have to define the load combination. For that we have to refer IS456. So let me open IS456 codebook. So here you can see in IS456 at page number 68, you can see here they have provided the combination of the different loads. First one is dead load plus live load, second one is dead load plus wind load, and third one is dead load plus live load plus wind load. Since we are designing our building for the static loading condition, we will select the dead load plus live load combination. For the dead load plus live load combination, the partial safety factor is 1.5 for limit state of collapse, and the partial safety factor is 1 for the limit state of serviceability. So let me close this, and here in order to define the load combination, we have to click on define, and then here select the load combination, and then click on add new combo. So we will name the combo as factored load. So this is for the limit state of collapse, so the partial safety factor will be 1.5, and we will add the live load. So here select the live, and the partial safety factor will be 1.5, and then click on OK. Now we will define another load case. So here we will name it as service load. The partial safety factor will be 1, and here we'll select live load. So I will click on OK. So here also click on OK. So we have successfully defined the load combination also. Now the next step is we have to analyze our model. For that, click on analyze, and then click on run analysis. So the analysis will take some time. Wait until the E-TABS does the analysis. So the analysis is completed. Here you can see this is the deformed shape of the structure. Now we have to see whether our structure satisfies the deflection criteria or not. For that we have to open the IS456 codebook. So here you can see in page number 37 of IS456 codebook, the maximum deflection including the effect of temperature creep shrinkage occurring after the erection of the partition wall and the application of the floor finish normally should not exceed span by 350 or 20 mm, whichever is less. So let me open E-TABS here. So here you can see the maximum span is 4.26 meter, which is around 4.3 meter. Let's calculate the value of the deflection. So I will enter the 4.3 meter divided by the 350, and this whole value should be multiplied by the 1000. So here I will enter R and then enter 20 mm. So the maximum deflection has to be minimum among these two values. So among these two values, the minimum is this one, that is 12.28 mm. So our deflection has to be less than this value. So let's check the maximum deflection in our structure. For that, let me close this, and here I will open the E-TABS. Okay, click on this window, and then here select this option. So the deformed shape, here select the combo, in this select the service load. So the deflection checking and the cracking comes under limit state of serviceability. So that's why here we have to select the load combination of service load. So then here select the automatic, and then here select the draw contours on the object, and then here select UZ displacement UZ, and then click on apply. So here you can see the maximum deflection is of 3.5 mm. So we are on the safer side. Just place the cursor at the point where we want to know the deflection. So we'll place at this grid. So the deflection at this point you can see is 1.676 meter. Here you can see there is a maximum deflection, that is the deflection of 3.735 mm. The deflection is within the permissible limit, so our structure is safe under a limit state of serviceability. Okay, now I will click on OK. So if you want to see the shear force and bending moment diagram, then click on the elevation and select any elevation. So I will select elevation 33. Click on this option, which is display frame pier spandrel link forces. So after that, here select combo, in that select factor, here select moment 22, and then click on apply. So here you can see this is the bending moment diagram of the column. If you want to see the bending moment about axis 3 3, then click on this option and then click on apply. So here you can see this is the bending moment diagram of the column and the beam along axis 3 3. So here you can see at the center there is a maximum bending moment of 31.237 kilonewton meter. So if you want to see the shear force, then click on shear and then click on apply. So this is the shear force diagram. So if you want to see everything in 3D, then click on 3D. So this is the shear force diagram of the entire structure. So that's it. Now I will click on OK. So the analysis is completed. Now the next and last step is designing of the structure. For that we will click on design and then here we will select concrete frame design and here we will select revise preferences. So here you can see this is the code which the E-TABS will use for the design, that is IS 456-2000, and there are other information. If you want to change this information then you can change. So I will not change this information, then click on OK and again click on the design and then here select design groups. So here select all and click on add and then click on OK and then again select design and here after that select design combination and then here select factor load and then click on this option and then click on OK. So the last step is again select on design and then here click on start design check. So structure is getting designed. So here you can see this is the design result. So here you can see these numbers. These numbers are the area of the steel in millimeter square. In this case it is the area of the longitudinal bars of the beam. So now after design there are certain checks and we have to perform those checks. For that click on design and then here select concrete frame section. So here click on verify analysis versus design section. So all concrete section are designed according to the analysis. So click on OK. Then again click on design. Here select concrete section and here select verify all members are passed. So here you can see all concrete frames were passed. No concrete frame is failed. So we will click on OK. So if you want to see this area of reinforcement in terms of percentage, then click on design again and then here concrete and here select display design info and then here select the rebar percentage and then click on apply. So here you can see the area of reinforcement is showing in terms of the percentage. Okay, the maximum percentage of reinforcement which is allowed in the beam is 4%. So here you can see the percentage of reinforcement is less than 4% and it is 0.23%, which is very less than 4%. We can say our design is economical. If you want to see the shear reinforcement, click on this box and then here select shear reinforcing and then click on apply. So here you can see the shear reinforcement is showing. So let me explain. At the end of the section we have to provide the shear reinforcement of 253 millimeter square and at the other end we have to provide the area of the steel as 253.39 millimeter square. At the mid also we have to provide the shear reinforcement of 253.39 millimeter square. So then if you want to see the column reinforcement, just click on elevation or 3D. I will click on 3D. So here you can see this is the reinforcement of the column and this is the shear reinforcement of the column. And if you want to see longitudinal reinforcement of the column, then here click on this box and then select the longitudinal reinforcement and then click on apply. So here you can see this is the longitudinal reinforcement required for the column. And if you want to see this longitudinal reinforcement in terms of percentage, then again click on rebar percentage and click on apply. So here you can see the percentage of reinforcement is 0.8%. So in the column you have to provide the minimum reinforcement of 0.8% and the maximum reinforcement is 4%. So here you can see all the columns, almost all the columns are designed for the minimum reinforcement criteria, so we can say that our design is economical. So now I will click on OK. So in this manner you can design any building using the E-TABS software. So the remaining parts are designing of the footing and the designing of the slab. For the designing of the footing, we have to know what are the moment and the load acting on the footing. For that, first click on this window and then select the plan view. In the plan view, select base and then click on apply. OK. Now click on display option. In this click on force test diagram. In this click on support reaction and then here select combo and here select service load and then here select FZ, MY and MX, then click on apply. So here you can see these are the support reaction. So if you want these in tabulated form, then click on tabulate and then click on apply. So here you can see this is the bending moment about x-axis and this is the bending moment about y-axis, and this is the load, that is the point load acting on the footing, that is 2.5 kilonewton. So using these data we can design the footing using any other software, or it or or we can directly export these data to the other software which are the foundation designing software, and we can design the foundation using this data. So I will click on OK here. Thank you guys, that's it for today. I will explain how to design the footing in next video.